I'm going to try and keep this fairly casual, so if you have any questions, just raise your hand or shout it out. Going to kind of really hit it in three main areas. First, I'm going to talk a little bit about myself so you know who I am and what I do. Then I will pop over to SolidWorks, show you how we use the costing tool, but I really want to spend the most of the time actually in the template editor showing you what we did and some of the things that worked for us. So real quick, and a few of you just kind of cross your fingers. I had a coffee incident this morning with my laptop, so I'm hoping it's going to hold out for me. So we'll see how it goes. And hopefully you don't mind if I come down here because I like to be down on the level. Just to give you a little idea about my background, who I am. Does anybody remember when antennas were actually outside the cell phones? That's where I cut my design teeth, designing those. Did that for several years. Injection molded parts, screw machine parts, high volume manufacturing. We were shipping probably 2.5 million antennas every month. Been there, done that. A couple of patents in the basement gathering dust. Then I moved on to, that's scaring me because it's moving really slow. Moved into something that I could walk around in instead of put in my pocket when I got into interiors for corporate and personal aircraft. Really cool industry. You get to see how the other half lives. Design cabinets that cost more in my house. High-tech materials, a lot of fun stuff. That's actually where I started using SolidWorks, and the guy who taught me SolidWorks is in here today, so hopefully I'll do him proud. After that, I went to a company that does automation equipment for purifying and bottling water. That's where I gained a true appreciation for the sheet metal tools in SolidWorks and large assemblies. That one there was probably about 8,000 parts. Did that for a while. That was when I got my CSWP and started the SolidWorks Users Group in Nebraska. After this, I got the opportunity / privilege to go work for the local SolidWorks VAR. So the one certification wasn't going to be enough. You got to get some more. So certified instructor, support tech, work group PDM support tech, enterprise PDM support tech, simulation pro support tech, and DriveWorks certified application engineer. And I was actually working on a couple others when I left, and if this is such a dream job, why would I leave? Well, the funny thing about working for a VAR is you get to know all the companies in your area. You get to go see what they do, meet the people, and tour their factories. You go out on a demo tour, doing on-site training, implementations. Made me realize how much I missed manufacturing. Love manufacturing. The highlight of that, though, was getting to share the stage with John Hirschtick for a presentation. And so stuff like that made it really hard to leave. But like I said, I really love manufacturing. So I found a little place named TMCO. Now, it was a little bit bigger than that when I started. That was when they first got up and going. I like that picture because it actually shows their first expansion. Went from the little steel building, okay, now we're getting bigger. Well, now it's a little bit bigger. It's actually everything in the yellow. So to give you a little history about the company, started in '74. In '85, they bought a little company called National Manufacturing. La-da-da. And in '99, my boss went to the owner and said, hey, I'd really like to start a division that makes artwork with the scrap that we generate. He's like, okay, we'll call it Metal and Art. In 2007, the owner went to my boss and said, hey, you're doing a good job with Metal and Art. How would you like to run National? He said, okay. He called me and I was like, yes. So, just so you know, National is this little building here. We're owned by the parent company, but they stuff us across the street in this little building so we get to do our own thing. We have the smallest parking lot because we all ride our bikes. And this right here is actually the original building. So what does National do? I'm not going to bore you with this. If you want to find out more, find me afterwards. I'll tell you about it until I'm blue in the face. We make lab equipment for bakery test labs. Basically, if you enjoy bread or anything made with dough, chances are it's gone through one of these to get the ultimate in quality when they're testing. Those were original national products. We have also started working with the USDA on ag-related products. This is one that I've done a lot of work with and I'm always happy to talk about, so find me, I'll tell you all about it. That one I actually have some parts that I'll be showing. The other side of my job that is fun, well that's fun too, but metal and art, just like the name sounds, we work with a lot of artists, national and local, and make artwork out of metal. This is a gazebo in one of the city parks that we did with a local architect that is entirely cut out of, it's laser cut steel, it's been powder coated. Over in Iowa, we had somebody approach us. There's a grain silo over there that they were going to tear down. Luckily, somebody had the foresight to go, hey, let's do something cool with it, maybe make it a focal point for the town. We put a 65-foot tall Corten corn stalk on it with some powder-coated aluminum panels to enhance it. Now it's the focal point of the town. We also do trade show booths. Did everything there, the motorcycle, the stand, and I believe that's actually my boss in the white. Anybody fly through Indianapolis? Next time you do, look up. We did all of those. So why did I subject you all this? I wanted to give you an idea of what it is we do, where I come from, and how we use the tool. And so this is apart from that one machine, and what I do is I'll look at that, and we'll fire up costing. And usually you're asked to cut the cost where you can. Well, on something like this, you need to have strength, you need to have rust resistance and all that. So this is where I go through my options, and I'll talk about that throughout this part here. I'm not going to go through the entire interface. I'm just going to touch on things. The template editor is where I want to spend most of my time, and as soon as I'm done showing these parts, that's where we're headed. I will talk about things that I like and I don't like. I love this here. It's a stupid little warning, but it's a flag for me that says this material right here is not the same thickness as my model. It's a good reminder. If I don't get enough coffee in the morning, preferably down my mouth, not in my backpack, I'm not that alert. I'm guilty. So, I've got a good idea here. This is going to be for a small run, so I'll put in 15 units. I wanted to point out a few things here. Bounding box, there's a couple different options there. I would say to go through them. I use bounding box strictly. I'll show you why in a little bit. Number of parts, and then there's my rough estimate on my part right now. I'm going to set that as my baseline because I want to do some comparison. And first thing that I really wanted to do was pin this. Okay, I know that this part's going to need to be rust proof. So one of the things that I may want to do is switch it over to stainless. Cost went through the roof. Stainless is more expensive by a long shot. So, and the material's a little bit different. I can get it close, but that's fairly close for stainless, so that's going to give me semi-apples to apples. Instead of doing stainless, what I might want to do is powder coat it. We have powder coat facilities, so I can do that. That's probably my favorite part about costing is this right here, add custom operation, because that allows me to tweak it as I go. So I will discuss all of these later. It's basically powder coat, PEM stud, weld, different operations that we also do to the part. This one, I'm just going to give it a standard powder coat, see what it does to the cost. all faces. I can pick them if I want, if we were going to tape it off or just do certain ones. But 1330 is significantly less than the stainless steel part, so yay, we're going to go that direction. That's all I'm going to do with this part. And then before I move on, just because I want to show some of the difference in the parts that I did, this one has 6 bends and 34 cut paths. I tried to get a lot of variety as I was doing my testing, and you'll see that here. This one's got a whopping 2 bends. It's got a lot more holes, but only 2 bends. I'm going to switch it to the correct thickness really quick and set my baseline. Now I'm not going to mess around with taking this one as stainless, but I am going to powder coat it with a standard color. And then this part happens to get PEM studs. Is anybody not familiar with PEM hardware? Okay, good. I'm a huge fan. So switch over to PEM studs. For this one, I'm not going to do all the edges. I'm going to select them. This is one that I do need to submit an enhancement request because I would like to see it not pre-select everything. And then I'm just going to grab a few edges where we'll put PEM studs, PEM nuts. I made it generic. I'll talk about that later. I'm going to pop in about 8 of these and see how that affects the cost. So now I've got a powder coated, PEM studded part, and I have a rough idea of what it's going to be. I chop through these fairly quick. I just wanted to show you. Now this is an uglier part because there's a lot more going on with this.
Do you have to change the thickness every single time?
I do have a few gripes about thickness. That one, the question was, do you have to change the thickness every time? I've had mixed results. For the most part, I do have to change it. It should recognize it in the model. I love that it gives me the flag, but one of the things, and this is really, really petty, but I'd like to see those in order. When you're in the template editor, you can put them in order, but it doesn't carry through to here. You can save it in the order that you want there, but it doesn't carry through. It's a stupid little thing, but you know, everything else is so awesome, bring it up. Okay, this part, fairly straightforward. I've got the metal. I'm going to set a baseline. I'm not going to do anything fancy with this. I'm just going to do my everyday operations to it so you can see how we use it. So, as you've seen with the other stuff, we powder coat because it's fairly inexpensive compared to going with stainless. I'm going to throw a few PEM studs in this. And then I'm actually going to throw in a few welds because they will be welding these tabs. And with the PEM studs, since it is selecting edges, you could probably be pretty generic because it's just counting them. With the welds, it's actually taking the length. So when you do your cost, you don't want to just grab anything. So I have a good idea of how much this part's going to cost. Bent, welded, this one has 8 bends to it. And one of the things that I'll talk about is getting a good variety because that'll highlight the numbers that are out when you're doing your testing. So I went over that really quick. Does that make sense? Okay, because what I want to do is have enough time that we can go through the template editor and still have some time for some questions. And we're we're doing pretty good. Okay, so the why is actually double. You know, it's like, well, why did I subject you to about me? Now it becomes, why do I like this tool? Why do I want to use it? The biggest one is, I want people to be able to do this stuff instead of them coming and bugging me or me going and bugging somebody else. Give people more power. Hopefully they use it responsibly. As you saw, I like to run through design scenarios. The one that I didn't do, bad Todd, was on the one with 2 bends. That one, let's say I wanted to save some money. I had that at a 12 gauge. I could drop it to 14 gauge and see what the cost difference is. And I've run it a few times, so I know that it's about $2. So it's not a huge amount since we're only running 15 parts. So $30. But that would give me a good guide to, well, I know that it's okay at 12 gauge. I might want to run some analysis if I drop it to 14 to make sure it's still strong enough. Do I want to spend that time? Well, to save $30, I'm not going to, because, you know, how much time am I going to spend? And contrary to what I'd like to believe, the ERP group in our company is not there to serve me. It drives me nuts, but I'm really a thorn in their side. I go over there and it's like, well, can I change? How much? What if we did this? And they just kind of got to the point where they've lost their taste for me. So now I need to get that ironed out before I go to them. So that's why I like it. How? How do you set it up? How do you do it? This is where I'm really bad at presentations, because I give you the secrets on slide 7. Best thing to do exactly what I didn't do. I found out what the tool could do, and I was like, awesome, I'm going to do all of this. I'm going to do, and I'm going to do all these materials. I'm going to do all this, and it gets really big and unwieldy really quick. So if you want to find out if you want to use it, do some testing first. Find out how it's going to work for you and your business. Start small. You're going to hear me say that all the time. I used to teach essentials for the VAR. I believe it's design intent was the drinking game. Every time you heard that, in this presentation, it starts small. Okay, one of the things that I kind of did when I was getting set up and ready to do this, do some research, find out what you're getting into. Best places to do it. The what's new. Even before I worked for a VAR, I'm a big geek. I would download the beta, install it. First thing I'd do is open up the what's new document and I'd print it out. 200 some pages, and I'd go through with a highlighter and go, this is awesome, cool. Best place for information. Rollouts. Your VAR should be doing rollouts. That's a great place to get information. Ours does an awesome job. User groups. I'd be a really poor user group leader if I didn't push them. That is the best place for you to get involved and get information. Find your user group. If you need help, see me afterwards. That is a great place to find out about this kind of thing. Forums. The SolidWorks forums, if you're not using them, shame on you. They've started a costing section. It's really good. It's not just me and 2 other guys. Great place for information. There's a lot of good articles up there. Articles. I found one on the forums written by Gerald Davis. I believe he's from Colorado. Awesome article, would have saved me a ton of time. Wish I would have found that before I got started. Webinars, SolidWorks, your VAR, great place. Presentations, hopefully I don't let you down. I'm going to try to give you some good information. Now, when you're ready to do this, first things first, before you do anything, figure out how you're going to use it. Is it going to be rough estimates, or are you doing actual quoting? I didn't show the forms. You can kick out of costing a really nice form with all the costs laid out. If you're doing actual quoting, you can use that. We are actually doing rough estimates. Next thing, depending on where you work, I've worked at a bunch of different places. It's all handled different. Talk to the people that will be involved. If they are going to do anything with this, just, hey, I'm looking at this tool in SolidWorks. Can I come to you with questions? You know, just give them fair warning. Get all the information. What I did here, I just went through the template editor, did screenshots, read them, figured out who I needed to ask for what information. So that way I could go, not waste their time, pop in, ask 3 questions, get my answers, go back to work. Save them time, they'll appreciate it. And then the biggest thing you can do is take known stuff. Take parts that you've been making for years that you have a very accurate price for and set them over here to the side. And they should be modeled up in SolidWorks already. Fire up costing, run them through. See how that number compares to the number you have on the books. And like the parts that you saw, do very different ones. And I actually did about 8 to 10 parts when I first started, just completely different. Some bends, one bend, no bends, PEM studs, powder coat, chrome plate, anodize. Give it a good variety. All right, now we get into the fun part. Template editor, like you saw, it's in the top right corner. You should know that by now. And what I'm going to do is just run through these different sections and just hit on, here's where I really screwed up, here's what I found works. All right. Nothing fancy on the general tab, it's just money. Moving on. Material tab. What were the 2 magic words? Start small. It gets unwieldy really quick, and this is where the snowball starts. So there are classes, and if you can kind of minimize these, it's going to help. Out of the box it'll have, I think it's 7 or 8 classes, and I was like, woohoo, I'm going to add about 5 more. Material, this is just the specific type within this class, and if you can consolidate these, and I'll talk about that more, it helps out a lot, especially with testing. And this is where Gerald's article was great, and I was going to bring it with me. It's now coffee soaked. Go to the costing forums and look through them, and there's a link to Gerald's article. Great article. It's a awesome read. Thickness tab. This is where it expands rapidly. That last screen there was like maybe 2 or 3 lines. I had 2 classes, 3 materials. Now all of a sudden I'm scrolling off the bottom just by adding thicknesses. So if you run a wide variety of thicknesses, it gets away from you really quick. So this one, you're just adding thickness in gauge, inches, and cost. If you double click right here in this bar, it'll sort by that column. When I found that out, thank you Richard Doyle, that was huge because that was one of my gripes. This is really where you decide how much time do you want to spend maintaining this. Because if material prices sway, you're going to have to change this. It does cut and paste really nice now. So I talked about snowballing. Biggest bit of advice I can give you is if you want to test it, if you're not sure if you want to use it or not, pick a material, pick a class, just pick a few thicknesses, work on a few parts, see how accurate you can get them, and go from there. Okay, the other thing that I'm doing is I'm just showing you how I got to some of these, and this material is straightforward. It's, how much is it per pound? But we run hot rolled, pickled, and oiled, cold rolled. I grouped them all together. Few cents per pound difference. I think that pickled and oiled is about 2 cents a pound more, cold rolled is about a nickel more. I kind of skewed it toward the high end. Because if I put all of those in individually, figure 12 thicknesses, hot rolled, 12 thicknesses, pickled and oiled, 12 thicknesses, cold rolled. Now all of a sudden I've got 36 different line items that I need to update. It starts rolling. Stainless steel, we use a lot of stainless steel. I narrowed it down to one type, 304, but we have different finishes and the cost is quite a bit different. I just kind of went toward the high side. I know in my head that if I'm doing a dull finish, it's going to come in a little bit high. That's okay. I'm just going for a ballpark. And that's the big thing to remember. If you are doing accurate costing, you're doing quoting, do separate line items for each of the finishes. It's going to be more work, but it's going to pay off. Aluminum, same way. We do a lot of 33. We do a lot of 50-52 and 60-61. The prices ramp up. In Gerald's article, he said, we do the same thing. We've spun it all up to 60-61, and I know that, and that way I'm never low on my bid. Brilliant. Thank you. Okay, cut tab. Broken up into length cut and stroke cut, cost per inch, cost per stroke. I have talked to a few people. I've witnessed it myself. This is where you're going to start tinkering with the prices, because they'll put in default values. And the first time I switched over to a punch part, went from laser to punch, the price went through the roof. Well, it was $2 a punch was the default value, and our punch will do like 1,200 punches a minute, which I wish I could get $2 for every time it slams, but we can't. Then just setup cost per machine. Most of them are going to be similar. Some of our machines are quicker setup. Biggest thing here is taking a look at what equipment you have to do the cutting, how you want to use it. This was another spot where I spun out of control because we have a water jet, and that one could be a job in itself because it'll cut pretty much anything up to 8 inches of concrete. So if I want to do all the different thicknesses of all these different materials, I could. Or I could just go over there and say, hey, how long is it going to take to cut this? And then I can take that number and I can figure it out. So the water jet's kind of an exception. Love it that we have it. I don't really want to build that database. We have a pair of punches. One is manual load, one's fully automatic. I wanted to account for that. It's like, oh, well, you know, the fully automatic should be cheaper because we don't have to have a man there doing it. Well, that'd be a second line item. And then when I'm populating everything else, it just expands. We have a dual laser cell with an elevator that feeds them. That's fully automatic. You just let that one go. I wanted to account for that, but both of those lasers you can run with and without nitrogen. That changes the cost. And then we have a fiber laser that's fully automated, and that one runs screamingly fast. So I had a ton of variables here. I dropped it down. I went to punch, laser, and water jet. And water jet's just a really rough cost. I didn't work in all of the little details. Here's how I figured it. Laser spec sheets, really good place because it's looking for cost per inch. So, you know, how much are you going to charge to cut this? I took the numbers from this and made a spreadsheet. You can kind of see it here. I did actually do punch and laser because they have different speeds, and I knew that I was going to do the length cut on the punch. And I just did some fictitious numbers because somebody that was supposed to get back to me wasn't getting back to me in a timely enough manner, so I said, well, I want a ballpark. And I just did a quick spreadsheet to say, if it can cut this fast and the machine costs this much per hour to run, how much is it costing per inch to cut? And then I could compare that to the laser software, which gives me similar information, and I can use that as a checkpoint because it will tell me machining time, cutting length. I can compare those to the numbers that I have. Very similar for the punch. Decide whether you're going to use stroke cut or length cut, as we all know I did length cut. Punch spec sheets, spreadsheet, you already saw that. Punch software. This would be really handy if I was going to use the stroke cut because it will tell me how many strokes it uses for each tool. Because this particular job had 17 tool changes, and it'll tell me how many strokes it used for each tool. This is that part that I showed that gets the bends, the welds, and the PEMs. And I just wanted to show this because when I costed it, I used the bounding box the entire outside, they managed to sneak in some other parts because they're awesome like that. I love those guys. Okay, bend tab. Cost per bend is pretty much all you're setting. Big thing here is the faster you can make bends, the less you can charge. So you can get, and I'm going to leave that to the business people, but it costs less. Setup cost, we have a bunch of different brakes. Difference isn't that much, so I just kind of aired toward the high side. And then you just, like I said, same with the laser. I'm just going to show different size presses depending on what material you're going to use. They're all pretty much CNC. The backstops will move automatically. They're about the same speed. Just a matter of size. Library features tab. If you're using louvers, anything from the library where you just drag it and drop it in, calculate here, we don't use it. So I'm just going to kind of move on. The template editor, like I said, the custom tab is my favorite by far because it lets me work in anything that I want. So we do powder coating in-house. I showed you that. I'm going to talk about that more in a sec. PEM hardware, showed you that. Welding, showed you that. Anodize, we actually send our anodizing and our plating out, but I could work with our vendors to get rough costs on that because I know their setup charge. And then surface area, there we go. We do laser engraving in-house. I can ballpark that. I don't necessarily want to draw out the laser engraved sign, but I can pick a small face and say, yeah, because most of it is setup cost. This is the one where I really want to add stuff in the future. All right, now this is where the calculations got really fun. Powder coat, I know that you can cover about 20 square feet with a pound of powder. I know how much a pound of powder costs. So I go to feed that in, and I'm going to back up a minute. We have several different flavors of powder, if you will. There's the standard that goes down the automated line. We buy tons and tons of that. There's the custom colors that go into the batch booth, and then there's the really crazy custom colors. So there's this huge swing in price. I kind of went with off the shelf and somewhere on the high end. I was going to work in about 3 or 4 different levels. It ended up being a whole lot easier to do this to get my ballpark. If I can get a little bit more into it, I'm going to continue to expand it. Okay, test often when you're doing this, because this is where I really screwed up. I put in, 20 square feet, cost this much, boom, 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 put it in. My first powder coated part was like $900 because it's looking for square inches. So just pay attention to the numbers. That's why I say to grab stuff off the shelf and know the numbers, because if it can break, I'll break it. PEM hardware, I got really lazy on this one. I'm just going to be honest. It's really pretty close. PEM studs, PEM nuts, all of those very similar in cost. It's not a huge swing. I just took an average. Cost of setup and operation is pretty much the same for all of them. And like I said, I'm just going for ballpark value. Okay, testing. I've been talking about it a little bit. This is where you want to really kind of go through and make sure that everything's coming out. I've been talking about comparing to existing items. I talked about using several different parts, and this is where I caught my bends being off, because I'd have a part with 1 bend, I'd have a part with 8 bends. It jumped out when I was switching between those, and I was charging, well, I hate to say it, but I was charging way too much for bends. So when I dropped the price, they balanced out. As with anything troubleshooting, just change one variable at a time. Don't go in and change, your material cost is going to be pretty straightforward, but don't change your setup cost and your per bend cost at the same time. Tweak them slowly, tweak one at a time. It makes it easier to fine tune. And then the best thing that you can do And this is dependent upon your company, because I know several companies, I've worked for a few of them, that somebody would do something, they'd throw it over the wall and they'd forget all about it. And then there was other ones where a person did everything. Go talk to the people that do this and get their input. You know, I literally just took my laptop around and said, hey, I'm working on this, and does this look right? Oh, that's way off. Thank you. Make my job easier so I can make your job easier. Okay, where do we go from here? All of us and me. I am going to continue to fine-tune this because, you know, I haven't hit the price exactly, but I'm pretty darn close, and I think I can get closer. As soon as I'm where I'm happy with that, then I'm going to start to blow out my materials. I'm just going to expand, because then I've found that magic formula, because the operations are where it kind of gets iffy. Material costs, that's straightforward. That's the easy part. I still want to add more to custom. I'm actually looking for random things to add just because it's cool. Looking for ways to make the maintenance easier, just updating it, you know, because as I start to add more materials, when I go through and need to make a change, that's a lot of stuff. If I can make that a little bit easier, that'd be awesome. One of the things that Gerald talked about was using multiple templates, and I'm seriously thinking about doing this and just having a template for punch, a template for laser, and a template for water jet, because that's really easy to toggle through. I didn't show this, but on the left-hand side of the screen where I showed you the cut paths, you can change those one at a time from laser to punch or water jet. There isn't an easy way to change them all. You can't select them all, at least not that I've found, and the only way that I've found to quickly change them is to go to the template editor, change the default, and then come back in. But if I had template set up, I could just grab that different template and go. So I'm going to look into that. I haven't even touched the milling and turning packages. That's a whole adventure waiting to happen. And I put off my CSWE this year to do some work on this, so I'll probably get around to doing that at some point. All right, I flew through that last part really quick. Are there any questions?
Yeah, it looks like it's one sheet metal piece at a time. No way to do an assembly.
Yes, thank you. It evaluates them one piece at a time, but there's a calculated cost custom property. And what I did was I made a custom property for cost and did it's SW- calculated cost. It's from the drop-down menu on your custom properties. And it'll populate that with the evaluated price. Then I put that in my bill of materials, and I can do a calculation there and get a total for my machine for the costing parts. There is a bug that's supposed to be fixed in Service Pack 2.0. Because there was a part that I was going to show that it was actually a small assembly, and it starts the auto close feature. So Service Pack 2.0 should fix that.
So it'll allow you to put in costs for welding 10 pieces together, then taking that sub-assembly, putting it in another sub-assembly.
It doesn't do that, but the way that I would work around that is, is if you got this piece going onto here, I would grab the edges that you're going to weld, cost them in with this, and then that way when you bring the assembly together, this has a little bit higher cost to show that weld.
All this material information is probably in your ERP system. Is there any way to get it over without keying all that stuff?
I haven't found a good way yet. I haven't dug too deep into that yet. I have looked at, because I've seen on the forums people asking for ways to bring it in from Excel or a different method. I have not seen a good way, and right now I've kept mine fairly small, and then when I do add one, because the material cost is going to be the same, Control C, Control V, Control C, Control V. Cut and paste. Wish I had a better answer. Anybody else?
Currently, if only 12 you can't do plate sizes. You can't do out a gauge. You know, that's
Oh, yeah, because once you get to a certain thickness, you have to put in that, you know, I haven't looked at that because I stopped at about 7 gauge. And that was actually, when I was originally looking at doing this, one of my considerations was plate is actually a penny a pound cheaper than sheet. And I was like, well, I'm just going to err to the high side. But I know what you're talking about because somebody said that they were just using fictitious numbers. You what?
once you put gauge in one line, you can't have that same value.
In the next, and I think what they were doing was they were just putting in a random number. the ugly patch. Anything else? I'm going to throw up,
Are the costs associated to the part file?
yes.
We have a different configuration and using design tables and configuration size changes.
So, okay, the question is, if you have a part with multiple configurations, is that cost tied to the configuration or the part? I believe it's tied to the active configuration. I could be wrong.
Are there API costs available to drive costs?
There are. That's the guy you want to talk to. He had a presentation yesterday. I'm going to throw up a few more things here. Contact info on Twitter. I blog. Like I said, I'd be a horrible user group leader if I didn't mention the user group. The person who ran it before me is here because I had to step down when I went to work for VAR and then I came back. She did an awesome job. And if you don't know me, I'm the guy that hands out key-based things at SolidWorks World every year. I'm a really big fan of the beverages that require an implement to get into. Really big fan of sheet metal. Really big fan of Wayne. Oh yeah. I do have several of these sheet metal gauges. I figured, well, sheet metal presentation, I'll bring some more. So if anybody wants one, just come up and see me. I got a whole stack. Any other questions? Oops. I'll get his real quick. Oh, okay.
We have a customer that sends their PEMs modeling part, and we've been fighting for several years on this. Is this going to screw that up? We did get them to make them separate bodies, not to merge them into the main solid, so we can turn them on and off.
Yeah, that would.
To delete them, or does it handle multi-bodies like that already?
Does it? It handles multi-bodies. Okay, the question was, customer uses PEM studs, but they actually model it into the part model as a separate body. You can turn off the bodies, so it should still be able to do the costing because it's looking at the edges to get the cut. Is that correct? Okay. Yeah, that's a big thing with us too. It's like, you know, do you do an assembly? Do you?
Does this only work with flattened patterns? You know, if you get a flat pattern, you can't get a flat pattern. I work with small clips, and it's the point where I can only make a good true sheet metal part, then I have to put some kind of form that
Will not flatten.
will not flatten.
That's a good one. Have you seen anything with that? I haven't run into that yet, but I know exactly what you're talking about, and my fear is that if it won't flatten, because when you saw me set the baseline, it pops through and it flattens it and then it brings it back. My fear is that it won't, but you can try it.
How do you handle scrap off your machines? Do you build that into your part costs?
Usually what we do is, well, you go back about 15 years, we start a business. As far as drop, when we figure we're using the bounding box, so the cost is into that, and if the part doesn't use all of it, we'll either nest something else in there or we sell it back. You know, we recycle it. And it's actually kind of nice the way the company works, because we do generate a lot of skeletons, just the empty sheet after the part's been cut out, and we'll hold on to those until the prices get good, and then we sell them all back, and then that's actually our profit sharing. So, big fans of that. Anything else? I have no idea what time it is. Okay, so we're a little bit early. If anybody wants, you know, a little sheet metal gauge with my contact info, just swing up and I'll pass them out. Any other questions? If you want to find out about any of the goofy stuff that I said about me, just find me later. Parts we make, stuff like that. I'll go on and on. But otherwise, thank you.